Guys, I want to talk about some questions I've gotten. So I want to start off by looking at something like this. Write tangent in terms of sine with this terminal point being in um, quadrant 4. So it's really helpful to have the definitions on page 409 and 415 down. The definitions on page 409, I refer to them as the unit circle definitions. You're going to have these memorized and be able to basically regurgitate them on every single test. Same thing with the stuff on page 415. These are what the book calls fundamental identities. What they, in this blue box on this page, refer to as the reciprocal identities, I usually refer to as the definitions in terms of other trig functions. Specifically in reference to a problem like what we're looking at, definitions in terms of other trig functions. As well as also on page 415, you need to have the 3 Pythagorean identities memorized. So tangent is defined to be sine over cosine, but sine is the same thing. Going off the definitions on page 409, it's the same thing as your y value as you trace around the unit circle, and the cosine is the same thing as your x value. Okay, so with a problem like these, writing a trig function in terms of another, the goal is to get the trig function that's before the phrase in terms of by itself on one side of the equal sign, and the trig function that's listed after the in terms of on the other side. So we encounter a problem here because tangent's defined to be sine over cosine. So we need to get rid of that cosine. So what we need to do is actually do another in terms of problem inside this in terms of problem. We need to write cosine in terms of sine. So we need to get cosine by itself and sines on the other side. So we could take this result and substitute it because cosine will be equal to cosine. We could substitute this into there and just have only sines. So it's really handy to remember now the Pythagorean identity listed on page 415. Sine squared plus cosine squared equals 1, which comes from the unit circle definition, the equation for the unit circle of x squared plus y squared equals 1. It's a circle centered at 0, 0 with a radius of 1. So we could take this equation and solve for cosine. So cosine squared equals 1 minus sine squared. Cosine equals the square root of 1 minus sine squared. And now we can substitute that up here. So now we have tangent is equal to sine over the square root of 1 minus sine squared. Okay. So now this is where the fact that this is in quadrant 4 is going to come in. So just a little bit of review about quadrants, but the coordinate plane is divided up into 4 quadrants. Quadrant 1, where both the x and y values are positive. Quadrant 2, where the x values are negative and the y values are positive. Quadrant 3, where everything's negative. And quadrant 4, where just the y values are negative. So, like I was saying earlier, if we have our unit circle and we're just tracing around, I start at standard position, positive x-axis here, and I start tracing around this circle to some point, some terminal point, the sine and cosine of that angle of rotation that I've just traced out is just the x and y value of where I end up. So what I just did here, I just traced out a 90-degree angle. But that's, if we want to think in radians, that's pi over 2. So we could say, since this is the unit circle, this radius is by definition 1. So the coordinates of this point are 0, comma 1. So we could say sine of 90 degrees or sine of pi over 2 is 1. And likewise, we could say cosine of 90 degrees or cosine of pi over 2 is 0. So in quadrant 4, tangent is it's y over x. And in quadrant 4, the y values are negative and the x values are positive, yielding the output of the tangent function is going to be a negative. If you have an odd number of negatives involved in multiplications or divisions, the result's going to be negative. So now what we need to do is look at adjusting our final result here to make sure that it matches the quadrant that we're told that this lives in. What I mean by that is in quadrant 4, the output of the sine function is the output. In other words, what we have in our numerator is already going to be negative. What we have to do is decide, and this is easy for people to forget. For example, when you take a square root, you actually get two answers, plus or minus 3, for example. So we have to decide whether we need to put a plus or a negative in front of this square root. And that's what I mean by just the final answer here. So the output of the sine function, in other words, the y value of any point in quadrant 4, in other words, the top of our numerator of this fraction for tangent here, is already negative. And we know that in quadrant 4, the tangent should also be negative because a negative y value divided by a positive x value should be negative. So we need this entire fraction here to be negative. So we have to decide whether we need a positive or a negative in our denominator to make this work out correctly. Well, in quadrant 4, our x values have to be positive. And that's what we have in our denominator of our fraction here. So this has to be a positive. So in point of fact, in this particular case, we don't actually need to do anything to our final answer. We just leave this as a positive 1 square root 1 minus sine squared. So for our final answer here, tangent of t equals sine of t over square root 1 minus sine squared of t. And I'll also note we actually did another example of writing a trig function in terms of another trig function within this problem, right? So I did a rewrite cosine in terms of sine in this problem. We did that by taking the Pythagorean theorem and rearranging it. The bottom line for these writing trig functions in terms of other trig functions is you need to have the Pythagorean identities memorized, and you need to have the definitions of the trig functions in terms of other trig functions, what the book refers to as the reciprocal fundamental identities on page 415 memorized. And when you're asked to write one trig function in terms of another, you need to kind of pull out of your brain one of those formulas, basically in that blue box on page 415, that relates those two trig functions and rearrange and manipulate it to have the trig function you're looking for by itself on one side and the other trig function on the other side. All right, well, I hope this was helpful, and thank you.